Hello, let's discuss divisibility. What is divisibility? For any number, we have to check if it is divisible by a certain another number. Let's say a number 74 and we have to check if it is divisible by 3. What are the rules to check it easily? Because if it's a bigger number, say a 5-digit or a 6-digit number, it becomes difficult to check if it's divisible by say a 10 or a 12 or a 15 or so on. So let's check the basic concepts, and for that we'll go back to prime numbers. The divisibility rule of 2. Now 2 is an even number. So all we need to check is if the number at the last place is even or not. But why the number at the last place? Now any number, let's say 74. So 74 can be written as 70 plus 4. Now in this case 70, which ends in a 0, is always divisible by 2, or any number which is say 74 can be written as 7 into 10 plus 4. So 7 into 10, now 10 is always divisible by 2. So all we need to check is the last digit, which is 4. Going by the same logic, if we extend it to say 74 is divisible by 4, or say 674 is divisible by 4 or not. Now 674 can be written as 6 into 100 plus 74. Now 100 is always divisible by 4. So all we need to check is if 74, the last two digits of a number, is divisible by 4 or not. Let's extend it further to a number 8. If we have to check say 5674 is divisible by 8 or not. Now let's break it further. 5 into 1000 plus 674. Now 1000, as we know, is divisible by 8. So all we need to do is 674 has to be checked. Similarly, if we go extend it further to more numbers like 16, 32 or 64. So since it was 3 digits for 8, it has to be 4 digits for 16, 5 digits for 32, and so on. So this is how the number divisibility for 2, 4, 8, 16, 32 can be checked very easily. Let's move ahead. Let's check about 3. How do we check if a number is divisible by 3 or not? Now here there is a different rule altogether. For 3, all we need to do is say 5674 has to be checked, then 5 plus 6 plus 7 plus 4, it has to be checked. Now that is nothing but the sum of all the digits that we are given in the number. So 5 plus 6 is what? 11, plus 7 is 18, plus 4 is 22. Now 22 we know is not divisible by 3. So 5674 is not divisible by 3. What about 9? Now 9 also follows the same rule. So sum of all the digits has to be divisible by 9 if a number has to be divisible by 9. So let's take a number 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. If we add up, it will be 1 plus 2 plus 3, which is 6, 4 plus 5 plus 6, which is 15. So 6 plus 15 is 21. It is divisible by 3, but not by 9. So 1, 2, 3, 4, 5, 6 is not divisible by 9. Let's go further. Let's take the next prime number, which is 5. What do we do about it? So if we go by the rule for 2, so any number, say 5, 6, 7, 4. Now 5, 6, 7, 4 can be broken into 5, 6, 4, which is 564 into 10 plus 4. So 10 is always divisible by 5. So all we need to do is to check the last digit. So it has to be either 5 or 0 in order to be divisible by 5. For 10, it's even simpler. The last digit has to be 0. Otherwise, it's not divisible by 10. Let's go ahead. What if we have the number 6 or say 12 or say 15 or say 18? Now for 6, we cannot do it for 6, but we can break it. If we check it for 2 and for 3, it has to be divisible by 6. For 12, if we check it for 4 as well as 3, it can be divisible by 12. For 15, if it is divisible by 3 and 5, it is divisible by 15. For 18, if it is divisible by 9 and 2, it is divisible by 18. So this is how complex, or rather say non-prime numbers, which can be broken down into simpler prime numbers, can also be checked just by breaking it down. Let's look at another prime number, 11. Now this is slightly different. A 2-digit prime number, how do we check it? Suppose the number is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a long number. How do we do it? So let's take the alternative numbers starting from anywhere. So if we start from the left, so say 1 plus 3 plus 5 plus 7 plus 9. Now this is nothing but 25. And the other set of numbers, so this was one set of numbers. What are the other set of numbers? 2 plus 4 plus 6 plus 8, which is 20. So you have 25 on one hand and 20 on the other hand. So this number, the difference of 25 and 20 comes to 5. Since this 5 is not divisible by 11, this number cannot be divided by 11 or is not divisible by 11. We can also extend it to other numbers. Let's check another number, 1331. So 1331, if we start doing it from the left, 1 plus 3 is 4, and the rest of the numbers, which is 3 plus 1, is again 4. So the difference is 0. Now, if the difference is 0 or a multiple of 11, it is divisible by 11. So 1331 is divisible by 11. Let's check it for another number, say 14641. So 14641, if we add the numbers, 1, 6 and 1 is 8. 4 and 4 is again 8. So the difference of 8 and 8 is 0. So 14641 is also divisible by 11. So let's apply this. Find out if a number, say 763, is prime or not. Now what do we check? How do we check? And till where do we check? So 763 has to be checked from what all numbers? If we start doing it, okay, a lot of people think that 763, let's try doing it till say 382 because it is half the number. But that is not correct. Let's look at what is the closest perfect square of 763. On one hand, it is 729, which is nothing but 27 square. On the other hand, it is 784, which is nothing but 28 square. So if we check up to 27 or say 28, then it is sufficient to say that if the number is prime or not. So let's start checking it. So let's take it for 2. So 763, the last digit is not even, so it is not divisible by 2. Let's check it for 3. So 7, 6, 3, so that's 16. 16 is not divisible by 3, so it is again not divisible. 4, I think we've checked for 2, so we don't need to check for any other multiples of 2. For 5, let's say the last number, which is 3, so it is not divisible by 5. Let's check it for 7, because that is the next prime number, so we are checking only for prime numbers. So 7, if we say, then it is 109, so it is divisible by 7. 763 divided by 7 is 109. So here we say that 763 is not a prime number, but at the same time we can say that 763 can be checked up to all the prime numbers till 28. So for 763, if we check for all the prime numbers till 28, we can confidently say that it's a prime number or not. This rule we can apply to numbers of any magnitude, say 5 digit, 6 digit or 7 digit or even more, and confidently say whether a number is prime or not.